Okay guys, we're back. In this video, I will teach you how to solve plain sailing. This plain sailing, and according to definition, plain sailing is a simple method of navigation which involves shorter solutions but less precise result, yet still within acceptable limits for practical navigation. Why plain sailing has a less precise result? Because the earth has natural distortion. The triangle that you may form in your paper is a perfect triangle, but when it was plotted on actual earth, and it will be affected by some distortions. We know our earth is an oblique spheroid, not a perfect flat or perfect sphere or anything like that. So we'll proceed here. As you can see the illustration, this is your position 1, meaning your present position, and you were intended to go here, your position 2. This will be your arrival point, and this is your latitude 1 parallel to the equator, and this is also your longitude 1. So you have your coordinates, longitude 1 which is parallel along to the prime meridian. So this is your dilat, the distance from your latitude 1 and latitude 2. The distance between that is what we call dilat, or difference of the latitude. So in here, your distance, this is your vessel's distance as it was proceeding from point 1 to point 2. The departure is the distance between the longitude 1 and longitude 2. In plain sailing, the term that we use is departure. That is the distance between two longitudes. So we can solve for plain sailing using a trigonometry. Just remember SOHCAHTOA. So meaning sine is equals to opposite over hypotenuse. Cosine adjacent over hypotenuse. TOA tangent over opposite over hypotenuse. So I draw a right triangle here for you to be able to understand. So in the right triangle, the adjacent part is the one on the bottom, and the opposite, why we call it opposite, because it was a opposite of the angle, opposite. And in the hypotenuse, the longest side is called hypotenuse. So we relate it, and it becomes the dilat. As you remember here, we have a triangle. We form a triangle as we proceeding from point 1 to point 2. We make a triangle. We just substitute it. We make it dilat as our adjacent, departure as our opposite, and distance as our hypotenuse. So this formula, cosine theta or cosine angle, is equals to adjacent over hypotenuse, cosine adjacent over hypotenuse. That is the meaning of that. And we transform it, we relate it on our plain sailing. So cos theta to find the cos theta, we need to have our dilat or our adjacent over the distance. So using this whole formula, we can solve for the distance also. We just need to cross multiply. We cross multiply distance times cos theta. This will become like this. Distance times cos theta, and then is equals to, this has always a figure of 1 as the denominator, and remaining here is equals to dilat. So to cancel out the cos theta, the remaining will become distance. So we will divide both sides by cos theta and then cancel it out. Distance is remaining, so the distance will be dilat equals cosine theta. So that is the formula for distance. Also, we can use tangent to find our coarse angle. So tan theta is equals to opposite over adjacent. As we come back here, tangent opposite over adjacent TOA. So we will relate it on our plane sailing. So tan theta is equals to departure over dilat. And now we will solve an example. So in this example, find the course and distance made good by a ship if she made a difference of latitude or dilat of 132 nautical miles north and a departure of 48 nautical mile east. So we have the given dilat of 132 nautical miles and departure of 48 nautical miles east. So we will going to solve for the course angle. So in this problem, we will use tan theta because our available given was the 132, which is dilat and the departure. So in tan theta, we have a departure over dilat. So we will just going to plug in. So departure 48, dilat 132. So we'll use the calculator to solve for that. 48 divided by 32. We come up with the answer, and then we need to shift the tan. So shift tan, and the answer is 19.28. We will round it up and will become 20. So 20 degrees, and the naming, we will put it here 20 degrees, and the naming is according to dilat and gilong. According to dilat and the departure. So you see here north, you see here east, meaning the dilat is north and the departure is east. So northeast 20 degrees. When we convert it in true north, we will come up with still 20 degrees true. So that is our cos angle. So now we will going to solve for distance. As I mentioned earlier, distance is equals to dilat over cos course angle, sorry. So we will just plug it in. We know our dilat is 132 nautical miles. 132 divided by cos 20 degree So we come up with 140 140.47 nautical miles. So that is how to get the distance of the plain sailing.